Today, we shall discuss the chapter of collisions. Not a chapter, we discuss the topic of collisions. Collision, let us suppose there is a jet and there is another object. This object is moving. This object, second object, it may be static, that means not moving, or may be moving, but with a slower speed. Then what will happen? At some point, they will collide. And after collision, the second object, which was moving in right-hand direction, will definitely continue to move in the right-hand direction, but at a speed equal to the earlier speed, or maybe more than the earlier speed, or maybe less than the earlier speed. That depends upon their comparative masses. And the second object, it may cut the same direction, or may even rebound back in the opposite direction, or become steady. This depends upon their relative masses. Now, what happens actually, if you concentrate here, actually what happens when they collide, the two bodies at the contact surface, they are slightly deformed. The contact surface, they are slightly deformed. The original shape of it was like this. Now it has become slightly deformed. This deformation, suppose it's a rubber ball. So it will deform, and this deformation creates a potential energy in the body. And immediately, it regains its original shape. Since we have already learned the chapter of potential energy, kinetic energy, etc., what happens when the ball was deformed? A potential energy is developed in the ball. And due to the elastic property of the ball, it regains its shape when the potential energy is again converted to this potential energy is again converted to kinetic energy. Now, this is due to elasticity. This is due to elasticity of the ball. Now, you have not yet learned the elasticity chapter. When you come to elasticity chapter, you will learn in detail about the properties of elasticity. For the time being, you just remember this is due to elastic property of the material. Now, in this world, no material is 100% or perfectly elastic. No material is 100% inelastic or non-elastic. But materials like steel, like rubber, they are very elastic, almost 100%. A rubber ball, if it is deformed like this, it will quickly regain its own shape. Similarly, if you have a steel coil and somehow it gets deformed with a huge force, it will quickly regain its shape. So these are, for the practical purposes, steel, rubber, these are these are elastic material or perfectly elastic. And what is a non-elastic or inelastic material? Let us say, let us say you have a lump of mud, of clay. If you hit a lump of mud or clay, it will be deformed like this. And the lump of mud will not regain its shape. So it is not elastic. Now, why we came to this point of elasticity? Because our chapter, we are considering elastic collision, perfectly elastic collision. Perfectly elastic. That means we are assuming the two bodies, when they impact with each other, there is a slight deformation and there is a generation of potential energy, and the bodies will immediately regain its own shape and potential energy will be converted to kinetic. This is the chapter we are considering today. So today we are at perfectly elastic collision. So we remove these things and write down that we are today at perfectly elastic collision. Shall generate our equations based on perfectly elastic collisions, and for next session we shall see what about things which are not perfectly elastic. One condition of perfectly elastic collision is kinetic energy as we have said that at the impact, during the impact, the two bodies may be deformed and it may create a potential energy, but quickly that potential energy will be converted to kinetic energy again. So kinetic energy of the two balls, some of the kinetic energy, the two balls before the collision and after the collision remains constant. Okay. With this, we start perfectly elastic collision. Let us take a body M1 and another body M2. We do not know their relative masses, which is bigger or which is small. And M2 is traveling with a speed of u2 and M1 is moving with a speed of u1. At some point, they collide. Right? Obviously, for collision, your E1 has to be more than E. Otherwise, it will not collide. The velocity of the first object has to be more than the second object so that they collide. This is the collision. After collision, this moves with a velocity of say v1. As we say, we do not know the direction of v1 at this moment, but we shall consider it the direction in the right hand direction. If our answer becomes negative, then we shall know it actually goes in the left hand direction. And we consider m2 travels with a velocity of right? Now, from the theory of conservation of linear momentum, equation of momentum you can write the momentum at the beginning was m1 u1 plus m2 u2 and momentum after collision was m1 u1 plus from this we can write m1 minus v1 minus v1 is minus v1. Now, from the principle of conservation of kinetic energy, conservation of principle of conservation of kinetic energy, you can write. Kinetic energy at the beginning was half m1 u1 square plus half m2 u2 square, and kinetic energy after collision was half m1 u1 square plus half m2 u2. From this equation, we can simplify the equation. We remove half from all cases. We remove half from m1. We have m1 u1 square here and m1 v1 square here. So m1 u1 square minus v. Let us say this is equation. We shall need it at some other time. Now from this equation, we can write this is m1 plus u1 multiplied by u1 minus u1 equal to m, sorry, v2 minus u2 multiplied. Now what do you do? You divide equation 3 1 equation 1. This is m1 minus v1. So what you are left with is from last on the right hand side, m2 will get cancelled. This is g2 minus u2 will get cancelled. You are left with g2 plus then becomes very simple. Now what we do, we take U1 or initial velocity on one side, on the left hand side. That means we get U1 minus U2, then to U2 minus. This is one important equation. We find here U1 is a larger speed, U2 is a smaller speed at the beginning, right? One is larger and smaller speed. That means U1 minus U2 is the relative velocity at approach, relative velocity before collision. That means relative velocity before collision. The left hand side. And what is the right hand side? V2 minus V1 is the difference of these two velocities, is the relative velocity after collision. So you have to just remember this. Relative velocity before collision is equal to relative velocity after collision. This equation will determine whether the whether the first body M1 will continue to move in the forward direction, or it will stop at the time of collision, or it will rebound backward. This equation will determine that, right? This is the first. Now, the second part. This is first part. Line of separation here. Second part. What we shall now do, we shall now find out the velocities. We shall now find out the velocities in terms of, shall find out the final velocities in terms of initial velocities. This is our job. We shall try to final velocities, final velocities v1 terms of here find out some expression for them. Right? And those expressions will be useful later on. So we find out. So let us first find out the velocity v1. Let us find out velocity v1. So let's find. In order to find v1, we use this equation. We can give this equation a name of equation 4. Let's find v1. So what do we do? From equation 4, what do we get? 1 minus u2, u1 minus u2 is equal to minus v1. This was our equation 4. Since we want to find out V1, so we eliminate V2. So from here, V2 is equal to, and here V2 is equal to U1 minus U2 plus U1. Then we go to equation 1. So now from equation 1 means this equation. From equation 1, we find M1 minus V1. Right-hand side was M2 because V2 minus U2. And V2 here is U1 minus plus V1, and we have another minus, another minus. From here we get, M1 U1 from U1 minus M1 U1 equal to M2 U1 M2 1 minus, there are two U2 minus 2 plus M2 V1. What we get here. So since we are trying to find out V1, bring all V1, this was our last equation, all V1 on the left-hand side. So here I have minus M1 V1, and here I have M2 V1. So if we take M1 V1 on the right-hand side, we shall have V1 multiplied by M1 plus M2. So M1 V1 we take on the right-hand side. And on the left-hand side, we shall have M1 U1 is equal to M1 1, and we shall have M2 U1 minus M2 plus this is equal to U1 not M1 U2, this is M1 U1. 1 U1 1 U1 minus M2 U1 plus 2 M2 U2. Okay. This is equal to, how we take M1 minus M. From here we find for V1, the final velocity of the first object, V1 is equal to M1 minus M2 1 minus m plus m2 into u plus 2 divided by m1 plus m2. Let us say this is equation 5. So here we have the final velocity v1 in terms of the two initial velocities, u1 and u2. Similarly, we can find the velocity. We can also find out. Now let us find the velocity v1, v2. We have already found v1. Let us find v2. And let us find v2. Similarly, from this equation 1, let me have a look at equation 1 now. It is called equation from equation 4. From equation 4, still I will show here. Let's find v2. Right? So from equation 4, that was this equation. If we want to find v2, we shall eliminate v1. We find that v1 is equal to v2 minus u1 plus u2 is equal to v2 minus u1 plus u2. Similarly, this equation 4, similarly from equation 1, that means this same equation 1 is this, 1 is this equation, 1 is this equation, equation 1 is this equation, right? From this equation, so this was from equation 1, we can write similarly from equation 1, from 1, we can write m2 minus u2 is equal to m1 plus u2. This was equation. This was actually equation 1. We have repeated here. So on the right hand side, m1 this v1 we replace by this v1 u1, so it will be minus v2 plus u1 and minus u. This is equal to m1. There are two u1s, so 2u1 minus v2 minus U2. Right? So our left-hand side was this and right-hand side is this. So side and this is the side equation. Now if we do multiplication from here we get M2 V2 minus M2 U2 into 2 on E1 2 M1 E1 minus M1 V2 minus M1 E2. From here we get, now we bring the V2 on the left hand side. V2 on the left, this is one V2 and there is another V. So M1 plus M2 into V2. Here we have M2 U2, here we have M1. So this M2 U2, when it comes to the right hand side, it will become plus M2 U2. So M2 minus M1 U2 plus 2. So from here we get final velocity of the second object is equal to M2 minus M1 divided by plus M2 plus 2 by M1 plus M. So let us consider this as equation 6. Let us consider this as equation 6. So here we have final velocities V1 and V2 in terms of the initial velocities of V1 and V2. But one thing I assured you that for your practical purposes, for numerical examples, etc., you will really not need these difficult equations. You will really not need these difficult equations. You may try or remember how to deduct them for the purpose of theoretical deduction. The final and initial velocities can be easier found from the equation that we derived earlier, that is relative velocity before collision is equal to after collision, right? Now, we have a few minutes left in this class. We shall try to find out that what is the, we shall try to find out the some special cases, right? Some, let us write some special cases. Some special. These special cases are of more importance. Let us take a special case A. When both bodies M1 and M2, they are same. it happens very often when you try to solve your numerical problems. The two bodies are of same mass, equal to, let us say, both of them are equal to m. Let us find out what is the initial velocity and final velocity at that, right? If this is so, then V1, this equation of V1, equation 5, equation of V1, this equation of 5, we'll find this first part, M1 minus M2 is 0. Second part, so V1 is equal to 0 plus, second part is 2m divided by 2m. So that means, and here V1 is equal to U2, and what is V2? V2, you go to this equation. Again, first part is 0. So V2 is equal to 1. That means the velocity before the collision and velocity after the collision, they just interchange. That means velocities interchange after the collision. And what was the velocity of the M1 will become the velocity of M2 after collision. And whatever was the velocity of M2 before collision will become the velocity of M1 after collision. This is one special case. Second special case. Second special case. Say U2 is equal to 0. What does it mean? That is, the second object was stationary. That means there is a M2, object M2 was stationary. Object M2 was stationary, and the object M1 just came and hit it. Then what happens? This happens very often in your practical life. Suppose, as I gave you an example yesterday, that suppose you were in a football match, you are playing in a football match, and you are stationary standing, but suddenly the ball comes and hits you. So it very often happens that the second object is stationary. If the second object is stationary, then see the U2 is 0, then equation of V1, in that case, equation of V1 equal to, from equation 5 again, M1 minus M2 divided by M1 plus M2, M1 minus M1 plus M2. So, since the U2 was 0 and V2, equation of comes, since U2 is 0, equation of V2 is 2m1 2m1 divided by plus m2. This is the equation. Now let us subdivide this. Now let us subdivide this into other part. The other part. First part, second part, third. Let us subdivide this. First condition is second object U2. Second object M2 was at static, so U2 was 0. In that case, equation of V1 and V2 becomes this. And let us say if M1 equal to M2 M, same mass, then what is V1? One is M1 minus M2 is 0. That means 0. And what is V2? By 2m into E1 is 0. So if the second object was stationary and the first object was moving and both of them are same mass, then what happens? The first object stops at the time of collision. It stops there. And the second object starts moving with the velocity of the first object. This is one case. Another case, let us say M1, that is the first object, is very heavy with respect to M2. First object is very heavy with respect to M2. And what is V1? Here M2 is very, very small. So it is M1 by M2 we ignore. M1 by M1 into U1 is equal to. That means if the first object is very small, then the first object velocity V1 after collision remains same as its velocity before collision. And what happens to the second object? V2. Here, M1 is very, very large. So 2M1 by M1. 2M1 by M1. Because here M2 is ignored in comparison to M1. Is equal to. That means if the second object was stationary and the first object is much, much larger than the second object, then the first object continues to move with its own speed, and the second object starts moving at the double of that speed. Third thing can happen where M1 all with respect to M2. Suppose M1 is a small ball, small rubber ball, and M2, let us say, is a huge iron ball. And that iron ball, M2 was stationary. Then what happens? Then, in that case, using once again, 1 is equal to, here M1 is ignored in terms of, in the reference to M2. If here M1 is ignored, then it becomes, U1 becomes minus M2 by M2 1 is equal to minus U. So here you see V1 is minus U. That means the second object is stationary and very heavy like an iron ball or a stone block or a stone wall. And M1 is a small ball. Then it will rebound. Its velocity becomes negative. It is rebound with the same velocity. Provided, of course, this is the perfectly elastic condition. That is why if you take a rubber ball and if you hit a wall, if you throw it to a wall, and if the ball is perfectly elastic, then it will rebound back to you with the same velocity. But as I said, nothing is perfectly elastic, so it rebounds back with a little less velocity. And here, V is equal to 2m1 by m1 equal to 2m1. So here m1 is very large, m2 is ignored. M1 is very large, M2 is ignored. Sorry, here I have made a mistake. I have written both of them same thing actually. It's not correct. I've written here M1 is much more than M2. Here I should write M1 is much less than M2. If M1 is much less than M2, then this equation M1 is cancelled. It becomes minus M2 by M2. And what this equation becomes, M1 is like cancelled. M1 is cancelled. So here it is 2m1 by m1. Here it is m1 by m2 u1, and m1 is very much less than m2. So this is almost equal to. That means if the second object is very heavy in comparison to the first object, the second object final velocity will be 0. That means it will not move at all. But the first object will rebound back with its own velocity. And if the first object is much heavier, then the first object will continue to move with its own velocity, and the second object will be thrown out at its double velocity. And if both the masses are same, the first object stops and the second object starts moving with the velocity of the first object, right? So these are the few properties of elastic collision. Next day we shall hear what we have got right from the beginning, what we have got, collision, and then we found out the properties of the perfectly elastic collision. This is perfectly elastic collision, right? These are the formulas. And next day, we shall see the equations for inelastic or partially elastic conditions.